morning everybody. Welcome to my video. In my videos I was discussing about programming with objects, and I'm Anusha, working as assistant professor in Computer Science and Engineering Department of Institute of Aeronautical Engineering. So we were discussing about the question bank. Now let's look into the next question, wherein the question is to explain about the features of Java or buzzwords of Java. So these are the various features which is Java is object oriented. It is simple, it is secure, platform independence, robust, portable, architecture neutral, dynamic, interpreted, high performance, multi-threaded and distributed. So these are the features of Java or the Java buzzwords. Now it is simple because Java has taken up the properties or the features from C and C++. It has taken the OOPS concept from C++ and syntax from C, because of which it made Java much simple to learn, easy to learn. Next is it is object oriented. So everything in Java is based on object oriented. It is all with classes and objects. Then it is robust because it has good memory management and exception handling mechanisms. So here as in C and C++, the programmers don't have to do explicit memory management, but here in Java it provides an automatic deallocation of memory for unused objects. So because of these features, Java is robust. Then it is multi-threaded, wherein it allows you to write programs which has multi-threads so that we can do many things simultaneously. So in one program itself we can have one piece of thread to read the arrays, then from another thread to sort it, another thread to find the average. So all these things can be run simultaneously. So that is the feature of multi-threading. Next is architectural neutral, or it is portable. It is because of the feature of Java virtual machine, wherein this JVM has something called as has the ability to process the Java code, the Java file. It will be converted into a bytecode, which is an intermediate code with dot class extension, and this bytecode can be read by all the JVMs irrespective of the OS in which it is installed. So let's say we have JDK installed on a Mac or on a Windows OS or on an Android, so Linux. So if these have JVMs, JDKs, when JDKs are installed, it will have JVMs in it. So these JVMs, let's say we have one program which is executed in Windows. So in Windows, it will generate a dot class bytecode. That bytecode can be taken and executed inside the Linux machine which is having JVM. So that there won't be any issues in that, and also it has high performance because of the just-in-time compiler. Next feature is it is distributed. So because it handles many internet operations with the help of TCP/IP protocols, and also it allows remote method invocation, which enables the program to invoke methods across a network. Next, it is dynamic, which verify and resolve access to objects at runtime, and also it dynamically link the codes. It is interpreted, wherein Java bytecode is interpreted and it is compiled into a machine-dependent code. Then it is high performance because of the just-in-time compiler, and it is highly secure because it is confining an applet to the execution environment, which doesn't allow access to other parts of the computer. Next question is to briefly describe about the JVM architecture. So this, as we have defined before. So let's say we are having a program sample.java which is .java file. So that will be compiled by the compiler, and it will check for the errors. We will resolve those errors and again compile. So once it compiles without error, you can execute it. So once it is not without errors, it will create a file with dot class extension. So this is called as the bytecode. This file is called as the bytecode, which is an intermediate code. Now this file can, let's say we are having JDK installed over OS, I mean Windows, Unix, Mac, etc. So the same dot class file can be executed by the different JVMs which is available, which is installed inside the OS. So this is what makes making Java different from C and C++. So the the magic of Java is about the bytecode and the JVM which is available. Next is JVM architecture. So JVM is an engine that provides runtime environment to drive Java code or applications. It converts Java bytecode into machine language. It is a part of the Java runtime environment. The architecture in Java contains class loader, memory area, execution engine, etc. The class loader is a subsystem used for loading class files. It performs the linking, loading, and initialization. The method area is the area wherein it stores the data structures, class structures like metadata, the constant runtime pool, and the code for methods. The heap, in the heap, all the objects and their related instance variables and arrays are stored. This memory is common and shared across multiple threads. The JVM language stack store local variables and their partial results. Each thread has its own JVM stack created simultaneously as the thread created. A new frame is created whenever a method is invoked, and it is deleted when the method invocation process is complete. Next, what is JVM, JRE, and JDK? The JVM is an abstract machine which is called the virtual machine because it doesn't physically exist. It provides a runtime environment in which Java bytecode can be interpreted and executed. It performs the main tasks like loading the code, verifying the code, executing the code, and providing runtime environment. The Java runtime environment, or the JRE, is the actual implementation of JVM. It consists of libraries and APIs required to execute data, a set of software tools which are used for developing Java applications, and it physically exists. And the Java Development Kit, or the JDK, is the one which consists of JRE and other tools to execute the Java code. So the JRE contains the JVM and the other libraries and files which is required for the execution of the program, and this other tools like JavaC and for compiling and execution is available inside the JDK. Next is to describe the usage of static block in the program with an example. So static means we create if we define any variable or any method as static, then it can be accessed without creating any object, or it will be shared among all the objects. So same memory location will be accessed by every object, and also before creating any object of the class, we can access these members. So if we define any member as static, then the static member can access only other static members. It cannot access any non-static members. So the one of the important static member is the main method, and since it is defined as static member, it is without creating an object of the class which contains main, it is being invoked. So that is the main reason by which the main reason for defining main as static is so that without creating an object of that method, of that class, it can invoke the main method. And also, if we define any variable or a method as static, then it will be shared among all the objects. Now, you can apply static keyword over a block or on a variable or on a function. So, when we define any block as static, it is that block which will be executed first when the class is loaded. So even before the main is executed or main is called, the static block contents will be executed. So if we want to initialize any elements, any variables, then we generally put inside a static block so that it will be executed and loaded. It will be executed and just when that class is being loaded onto the memory. So it is a static block which will be executed first. Now we can also define a variable as static variable, and they are also called as class variables or global variables, and they are they they are the properties which is common to all the objects of that particular class. So if we have any variable which is defined as static, then if we have a class A and we have a variable A which is static, this variable A is static, and then we create 3 objects of this class, then the variable A will have some memory assigned, isn't it? So that memory will be used by all the 3 objects. So if say this first object is assigning A to 10, B to 20 and C to 30, then the final value which A has will be, let's say, will be 30. Like if C has changed the value of this variable A to end. Sorry, if this object C has changed the value of A. Let's say we are having this class A and variable A, and you are creating 3 objects P, Q and R. So P is setting A's value to 10, Q is setting A's value to 20 and R is setting A's value to 30. So let's say R is the one which changed the value of A to 30 at the end. Then A's value will be 30 at that time. Because all the variables are all these objects are sharing this static variable A. And if you want to access this static variable, you just have to, so if you want to access any static variable, then you can call that element with the class name. So if you can access it as A dot A, since A is a static variable inside the class A. The default value for the numbers, for static numbers, number variable will be 0. For Boolean, it will be false. And for object references, it will be null. Next, again, you can access static methods. So these static methods can access only other static member, and you cannot access it using this and the super keywords. So let's have an example. Here we have this program wherein our main method is inside the use static, and we have one static block. This is our static block defined, and we have the main method, and there are 2 classes, static demo and use static. Now, so when the class will be loaded, what happens? It is a static block and all the static members will be initialized. So it will be initializing A, B, C, D, and it will be displaying all these statements. So so when the output comes, you will get the statement this first. Static block is entered. A's value will be displayed. A's value 3. B will be 12 and B's value will be displayed, and you get the static block left printed. Then after that only the statement entered main will be seen. Now inside static demo we have 2 variables C and D and a static method call me, and inside use static we have 2 variables A and B which are static and a static method Now inside main we are calling the method. So this meth is a static method and main is also static. So without any problem you can call it. So when meth is called, 42 will be passed here. So x is 42. So x value 42 will be printed. A is 3 and B is 12. Then call me is the static method inside the static demo class. So when you try to before that, here we are trying to access the y variable. The y variable is not a static member, so we cannot print this. This statement will display an error since y is a non-static member. Y is a non-static member of useStatic and meth is a static member. So a static member cannot access a non-static member. So this line will display error in case you try to execute it. So after displaying all this, it will come here to call the static demo call me. So this call me method is again a static member of the demo class. So main can access it, and when main want to call the static call me method, it has to access using the it can directly access without using the class. Sorry, without creating an object, by just making use of the class name, it can invoke the static method. So class name dot that method name. So inside call me, it will display the value of C. Now, if we want to access the D value, which is again a static member of demo class, static demo class, so you call it with its class name, static demo.d. So this is about static members. Next is to discuss about various conditional statements in Java with suitable examples. So there are different types of control statements in Java. They are conditional statements or selection statements, the loop or the iterative statements, and the flow control or the jump statements. So under the conditional statements, we have the if else, the if else if, and the switch. So the if, how does if block works? You will have some condition. If this condition is true, then it will execute its body. The if else will have, again, if will have some condition. Some condition will be tested. If this condition is true, it will execute this body. Else, if the condition is false, it will come and execute the else part. Now the if else if ladder, you have if condition, this will execute, this body will be executed. Else if this is false, it will come and check this condition. If this condition is true, it will execute this body, and again if this condition is false, it will come and execute the else part. So this is if without else, and this is with if single else, and if this is the else if else, the if else ladder. And another control statement is the switch case statement. So here it will enable us to accept, select one of these case based on this expression or the variable. So let's say we are having some ch, which is some expression or variable. So based on this value of ch, if to whatever case value this ch is matching to, that set of statement will be executed. So let's say if we have this case is having 0, this is 1, and like that. So if ch was 0, it will check, the ch will be checked with this value, and whichever it is matching to. So here it found that it is matching to the first case itself. So the whole case block will be executed. Now this break statement is compulsory in switch case, or else it will execute all the fall through statement. So whatever case continues after this case, the matching case also will be executed. So to prevent that, we have to make use of the break statement in case, switch case. And if none of these values are matching, then if we have a default case, then that default set of statements will be executed. So this is a switch statement is a substitute of if else ladder. So let's look into a small example. So here we are having the ch, which is the choice, to read our choice, and some variables initialized. So this is to execute a menu based calculator type. So we are doing the addition, subtraction, multiplication, division, and modulo operation of 2 elements. So we are statically initializing these 2 elements, A to 5 and B to 5. And so in the output, we will first get it as menu. 1 is add, 2 is subtract, 3 is multiply, 4 is divide, 5 is modulo, and choose one. So when we give that element, let's say we are taking 3. So what will 3 do? 3 is for multiplication. So our choice is, we have to choose one, and you have to read the choice. So when you read the choice will be read as 3. So ch is 3. Now it will check what is 3 is switch chi. So ch is 3 now. So is 3 matching to this case? No, it is not matching. So it will skip this case. Is 3 and 2 case 2 matching? No, so it will skip this one also. Now 3 and 3 will be checked. So this is the matching case. So what will happen? It will find the product and display it. And since we have a break statement here, none of these statements will be executed and it will come out. Now if you want to continue, you have to give either 1 or 0. So in case it is taking to, it will continue if our if we give 1, it will continue this loop, or else it will exit. So based on the 1, and if we give 1 here, then this again these operations will be continued. If we give 0, it will be stopped. So that's all for today's video. To prepare my slides, I had used Herbert Shield Complete Reference 9th edition. Then all these websites, Java tutorial website, Java T Point, and Samantha's website. So that is all for today. Thank you for watching my video. We'll continue in the next class.
Like, share and subscribe. Hit the bell icon for more updates.